Hello, welcome back to the channel. So let's continue our previous video on numerical integration, but this time let's do a different problem. Instead of calculating a bound for the error, this time we'll calculate the value of n, the value of the subintervals which will guarantee the trapezoidal rule approximation with an absolute error less than 0.001. So you'll use the same process, which you used in the previous videos, the same inequalities as well, but now instead of calculating the ET, you'll calculate the value of n, which will guarantee the absolute error caused by your trapezoidal rule approximation to be less than 0.001. So now what we want is, we know that the error is given by, for the trapezoidal rule is given by this formula, m times b minus a upon 12n square, b minus a to the whole cube, and we want this error, we want this ET to be less than 0.001, right? So we want this value to be less than 0.001, and in order to achieve this, we want to calculate the value of n which will make this happen, right? So now before doing that, again the first process is to calculate the value of capital M, and we know that in trapezoidal rule the value of capital M is determined by this equation, right? So now we want to calculate the upper bound on the absolute value of the second derivative of f of x, right? And we have been given this information over here that our x is varying from 1 to 4, which will provide us our a and b values. But what's more important is this equation over here, right? We know that the double derivative of f of x is varying between -2 and 0 for all the values which lie in the interval for which we are calculating the trapezoidal approximation, right? So now we know that the second derivative of f of x is varying between -2 and 0. Since we are concerned with the absolute value of the double derivative of f of x, we can clearly see that if we want to calculate an upper bound on the double derivative of f of x, the absolute value of the double derivative of f of x, based on this given information, we can clearly see that the absolute value of the double derivative of f of x is less than equal to 2, right? Because the double derivative of f of x is varying from -2 to 0, and the absolute value of the double derivative of f of x would have its maximum value at this value, right? So now since we know that we were concerned with the absolute value, which came out to be less than equal to 2, which means our m is equal to 2 in this case, right? So now we have the value of m, we also have the values of b and a. The value of b is 4, the value of a is 1, and then if we'll plug in all these values into this equation, we will get a value of n, or the value of subintervals, which will cause the absolute error to be less than 0.001. So let's solve this. So now we know that the value of m is 2. So 2 times b is 4, a is 1, and 12n square is less than 0.001. So now 2 times 3 cube upon 12n square is less than 0.001. So n square, I'll shift the n square to this side, n square should be greater than 2 times 3 cube is 27 upon 12 times 0.001. We can write 0.001 as simply 1 upon 1000, right? And if you'll solve this, n square should be greater than 4500. And if n square is greater than 4500, if you'll calculate this equation, your n should be greater than approximately 67.01 in this case. And since we know that our n has to be a whole number, our n should be equal to 68 in this case, right? Because we'll have to take our n value to be greater than 67.01, and we also want our n to be whole number. So the next whole number which comes after this value is 68. So if we have these number of subintervals, we will be guaranteed that the trapezoidal rule approximation will have an absolute error less than 0.001 in this case. So that's it for this video. Again, the main takeaway from this video is you'll again use the same formulas, the same approaches in order to solve these type of questions when you have to calculate the value of subintervals. The only difference in these type of questions would be, instead of being given the value of n, you'll be given the value of the error in these type of questions. So feel free to comment down in this video if you have any doubts. Follow the channel in order to get notified about the other videos that I'll be uploading. Stay tuned. Thank you so much for watching. Bye bye. Take care.